Hello viewers, welcome to my channel and thank you for watching the videos. In this video, question number 5A of 1995 UPSC CSE Maths Optional Paper 2 Complex Analysis. Here we have been given let uxy is equal to 3x square y plus 2x square minus y cube minus 2y square. Prove that u is harmonic. And second part is find a harmonic function v such that u plus iv is an analytic function of z. So for a function to be harmonic, we need to show, suppose u we are taking, so del square u upon del x square plus del square v plus del square u upon del y square is equal to 0. And then we will find v. For that also we have to show that del square v upon del x square plus del square v upon del y square is equal to 0. But before that we have to find out the function. So first we show that u is harmonic. We differentiate it partially with respect to x and y. So here del u upon del x, we get, this is from this function we get 6xy plus 4x. Partially with respect to y we get 3x square minus 3y square from this term minus 4y from this term. Second time differentiation is this, and if you see visibly it is clearly that we add them and it is coming to 0. This is harmonic function, u is harmonic. Now for finding v, we first get f dash z. Fz is equal to u plus iv, where v is to be determined that fz is analytic and v is harmonic. So v and u will satisfy Cauchy-Riemann equations. These are standard equations, well known. Del u upon del x is del v upon del y, del u upon del y is minus del v upon del x. So f dash z, when we differentiate it with respect to x, will give this value del u upon del x plus I del v upon del x. So we use Cauchy-Riemann, and instead of del v upon del x we put del u upon del y. These two terms we have calculated. Del u upon del x and del u upon del y we have calculated. Substitute these values and in place of x plus iy put z. So here this is 4x plus iy is 4z, and this can be written as x plus iy square whole square, which gives x square plus I square y square. I square is minus 1 plus 2ixy. So we got f dash z. Now we have to find out fz, so we will integrate it. So integration gives us 4z square by 2. This is 2z square, and from here 3 will cancel out, so minus I. So we got this 2z square minus iz cube. In place of z we put x plus iy and open it. So we get real term and imaginary term. So coefficient of imaginary term is v. We got v. Now we calculate del v upon del x and del v upon del y, partially differentiating with respect to x and y. Second time differentiation. So we add them and show that it is 0. It means v is harmonic function. So we have obtained fz in terms of z as well as in terms of x and y. And in terms of z it is here. In terms of x and y it is here. And we have shown that u and v are harmonic functions. Thank you.